Hi, welcome back. So this time we'll do the vector addition using the what we call the graphical method. Okay. So once again we have two main approach or main method. We have first what we call the parallelogram method, or the what we call the tail to tail method, and the other one is what we call the polygon method, or head to tail method. Okay. So first, let's now have an example using the parallelogram method or tail to tail approach to add two vectors in graphical. By the way, both parallelogram and polygon method needs a ruler and a protractor. So prepare your ruler and your protractor. For now, I don't have protractor, so I will be using only the ruler. But for your activity, you need both the ruler and the protractor. Okay. So this time, let's now have an example to add two vectors graphically using the parallelogram method. For an example, we have two vectors here, vector A and vector B. Vector A has 100 units going to the right direction, and vector B has 50 units going to the upward direction. So our first step is to choose scale. So ignore using ruler, you must choose your scale to represent this magnitude here, the 100 or 50 units here. So for the meantime, let's use first just scale. Let's use 10 units. 10 units is equal to about 1 cm. So it only means that every 10 units is every centimeter is equivalent to 10 units of our sample. Okay. So if we need 100 units, how many centimeter do we need? So later on, let's convert the value of our vector A and vector B so that we can determine how many centimeter do we need to draw in our plane. Okay. So for vector A, it has 100 units. So how many centimeter are there in 100 units? So using our scale, we can now convert the 100 units into centimeter. Okay. So 100 units times our conversion factor, our scale, is that we have 10 units for every centimeter. So what we have here, cancel out, is that we only need 10 centimeter. 100 divided 10 is 10. Okay. So we have 100 centimeter, I mean 10 centimeter, 1 to the power 10 centimeter to represent our 100 units magnitude here. Okay. So for vector B, we have 50 units. So how many centimeters is that? This is 10, about 50. So we have 50 units times our conversion factor, or our scale is, we have 10 units per cm. So we have 50 divided 10 instead of 5 cm. So instead of putting 50 units in our paper, we can now draw 5 cm to represent our 50 units. Okay, so after we choose scale and convert our vectors, we can now proceed to step 2. Okay, so let's now draw Cartesian plane and plot the two vectors from tail to tail. So let's now draw Cartesian plane, our x and y coordinates. For example, this is now our Cartesian plane, the x and y plane. Okay, so draw the Cartesian plane and plot the two vectors from tail to tail. So where is our vector? We have vector A and vector B. So our vector A, let's now plot our vector A 100 units to the right. So from our origin, we need to draw 100 units to the right, going to the x direction. But since we say that our 100 units is equal to 10 centimeter, we can now use our ruler to draw 10 centimeter, which represents 100 unit vector A. So we have 100 units vector A. Oh, sorry. I need to extend my x-axis. Okay, x-axis. So we need to draw 10 cm to represent our vector A. Okay, don't forget to include arrow on your drawing to represent that this line is a vector. So let's name this vector A 100 units or 10 cm, which is equal to 10 cm. And then let's now plot our vector B, which is 50 units or 5 cm. Going, what is the direction of our vector B? Upward. So again, from the origin, you need to draw 5 cm upward. This is my 5. Okay. So this is now our vector B, which is 50 units or 5 cm. So after that, plot the two vectors from tail to tail. Okay. So from tail to tail, since this is the tail of our vector A, and after that we draw vector B from its tail or from the origin. Okay. So that's why it is called tail to tail method. It's from tail or vector A, we draw the vector B from tail to tail. So using the scale, draw the magnitude of the vector. I've also done this. And use protractor to plot the direction. It is happened that our direction is along x and y axis. That's why we don't need the use of the protractor. But for the other example, we need to use the protractor to indicate the direction of the vector. Okay. And then after that, we need to draw the dashed line parallel to the vectors to make the parallelogram. So we need to draw we need to draw parallel lines to vector A and vector E from the tip of these two vectors. So from the head of vector A, we need to draw a parallel line of vector B here. And from the tip of vector B, we need to draw a parallel line of vector A there. So from that, we can now create a parallelogram. So from the tip, we need to draw again 5 units or 5 cm going upward. Make sure that it is a parallel line. Then parallel line. Apo. Okay. So in our step, it says that draw 2 dash line, but in my case, I used a different color. It's to to indicate that it is the line that says here in step 3. But you can also use dash line if you want, as long as the vectors a and b are parallel to our original vectors here. Okay, so from here you can now see that we can already create a parallelogram. Okay, so from here we need to proceed to step 4, which says that draw the resultant vector from the origin to the opposite corner of the parallelogram. So our now resultant is that we need to draw a line from origin to the opposite corner of our parallelogram. So this is now our resultant. So this is now our resultant. Then use ruler and protractor to determine the magnitude and the direction of the resultant. So since we only have ruler, we can now determine the magnitude of this resultant here. So from here it says that 1, 2, 3, 4, 5, 6, 11. It's about 11 centimeter length. And then for the direction, you need to use protractor. Okay. So in my case, I don't have protractor. I think it is about around let's say 27 degrees. Okay, so that is only an assumption. So after that, we proceed to step 5. Convert or determine the value of the resultant by using the chosen scale. Since this is in terms of centimeter, but what we want to an answer is we need to convert back the centimeter into units. So using our scale, we have 10 units is equal to 1 centimeter. We can now convert back our resultant to determine how many units is this. So our conversion factor is that 10 units 1 centimeter. So we need to place 1 centimeter here and 10 units there to cancel out 10 units. So we have 11 times 10 divided 1, we have 110 units. Okay, so our resultant here is 110 units. So our resultant here is 110 units. 110 units, 27 degree from positive x-axis. 27 degree from positive x-axis. Okay. So it only means that when we add vector A and vector B, the result will be 110 units, 27 degree from positive x-axis.